Oh, hello again, and welcome to the video on chapter 2 of structural theory. So, chapter 2 is the analysis of statically determinate trusses. So, this is an example of trusses. This is bridge trusses made of steel. So, in this topic, we want to basically know what is trusses, how to classify trusses, and lastly, to analyze the forces in trusses. So first chapter, there's common types of trusses. First chapter, what is a common type of trusses, and then we take a look at the classification of trusses. Is it determinate, indeterminate? And then we're gonna learn about method of joints, how to analyze forces in trusses using method of joints, where you take a look, where you analyze the joints. Then a zero force member, how to identify zero force member, because sometimes trusses you have a zero force member where the member is doesn't have any forces acting on it. It will shorten your analysis step. And then last one is we want to learn about we want to talk about method of sections. This is first method and then this second method. Both can be used. Both has pro and cons, but in the end, both produce the analysis, the forces. Both helps finding the forces within the member of trusses. So let's start our topic with common type of trusses. Common type of trusses. Truss is a structure composed of slender beams and joined together at their endpoints. So members join at endpoints. So the joint connections are usually formed by bolting. This is bolt or welding, where you weld the edges of members to the plate. It's usually called gusset plate. Um, Gusset plate. So planar trusses lie in a single plane uh, and bridges. So planar truss, a plane trusses within a plane. So it's a one single plane. So your trusses lie within that plane only. Because you also have space truss. This is space truss. If you have ever encountered in on the roadside or on the uh, bridges, or usually some stadium, mostly stadium that carries the roof of the stadium usually use space truss, where it does not lie only on single plane but on like a three dimensional plane. So the trusses lie on many planes. So, but mostly you want to analyze is the planar trusses or coplanar trusses. So, common type of trusses, roof trusses. This is commonly found in houses, residential area, and also on in industrial building. Roof load is transmitted to the trusses at the joints by means of series of purlins. Purlin like beam joists, but for roof they call it purlins. You have these purlins. So load from the roof itself, and also rain, snow. So the load transmitted from the roof slab or the roof tile towards the purlins, and then purlins acting on the purlins transmit the load to the joint to keep the frame rigid and thereby capable of resisting horizontal wind forces. Knee braces are sometimes used at the supporting column. So this is knee braces because you might afraid that the bottom truss here would give way like this. You're afraid this will happen, so you add knee braces. Common type of roof trusses. This is from the book. So you have scissors, how Howie, Pratt, Fan, Fink. So this is two very common. But this one is slightly less common, but gives you some access here. It gives you access for any maintenance, or you want to do some insulation on your beam. So this provide you access. Warren sawtooth. This is industrial. This is for factory. Factory. A 3-inch arch. So this is for larger structure. And bowstring. So this is more like a banquet hall. Next is bridge trusses. The load on the deck. So when there's a bridge, you have a deck where the car or you crossing by the river. So the deck is called or the slab deck. So in bridge truss you have deck. So instead of roof cladding, you have a bridge deck. So bridge deck transfer the load from you, from the car traffic towards the stringers here, like purlins, and then stringers transfer the load to the floor beams. The floor beams. This is your floor beam, or sometimes they call it pier or trans like crossing beams, because it's not longitudinal, it's a transverse beam, and then towards the joints or your supporting truss. So lastly the beams transfer the load to your truss here. So this is your truss. The top and bottom chords of these side trusses are connected by top and bottom lateral bracing, which resist the lateral force. This is your lateral bracing. This is your top chord. So the top and bottom chords connected by the lateral bracing. This is your lateral bracing. So common types: Parker, Baltimore, Pratt, Howe, Warren, subdivided Warren, and K-truss. Usually you can see this type of bridge trusses in like very old steel bridges, like in Baling, or bridge crossing at KL near Neseputih. So they have this. Just additional information: in case of long span trusses, roller is provided. Roller at the end is provided because you want to compensate for thermal expansion, and you don't want the bridge to like having buckling here because of the expansion. So you provide roller so the beam can expand laterally. Assumptions for design: the members are joined together by smooth pins. This is assumed because we assume this so that there is no friction occurs between the pin and the joint. So there is no reaction on the pin, so it will be purely X and Y forces. All things are applied at joints. We assume loadings are applied at the joint. It will be simplified the calculation. Due to the two assumptions, each truss members act as an axial forces. Axial force. So your tie rod, for example, the force is acting actually at the axis of the member. So there will be no moment. Simple, compound, or complex truss. Complex truss. So a simple truss. This is a classification. Number one is simple. Number two, compound, combination of trusses, and then number three is complex truss or space truss. Second, a simple truss, to prevent collapse, the framework of a truss must be rigid. So the simplest framework that is rigid or stable is triangle. So you add triangle here, so it will be rigid. If not, this truss will collapse. A simple truss is a basic stable triangle element as ABC, A, B, C. So it's a triangle. The remainder of the joints D, E, F are established in alphabetical sequence. A simple truss do not have to consist entirely of triangles. So you can have this trapezium here. So that's simple truss. Basic stable triangle trusses. Compound truss is combination, as the name implies, compound, combine. It's formed by connecting two or more simple trusses. So you connect two triangles. Often this type of truss is used to support loads acting over a larger span, so like bridge, as it is cheaper to construct a lighter compound truss than a heavier simple truss. Rather than you have a big triangle, it's better to have a smaller triangle to become a whole truss unit. So the member will be smaller compared to a heavier simple truss. The size of a member of your truss. Classification of coplanar trusses. A compound. Type 1, the trusses may be connected by a common joint and bar. Type 2, by 3 bars. And then type 3, the trusses may be joined where bars of a large simple truss, or the main truss, have been substituted by simple truss called secondary trusses. So type 3 compound truss is more complex, where you have a combination of simple truss, which replacing um, the large simple truss. You have a secondary simple truss. So this is example. So this is a simple truss, two simple truss combined. So you have a compound trusses. And then this is a type 2. You have simple trusses being combined with bars. So it become a compound trusses also. And then this is the last one, the more complex one, type 3. 2, 1. So type 3, your secondary simple trusses, replacing your main bar large. Instead of you have a large simple trusses, so the members being replaced by secondary simple trusses. So overall, it's like you have more simple truss compared to number 2 and number 1. So this is for larger structure. Last one is a complex truss. A complex truss is the one that cannot be classified as either being simple or compound. So as you can see here, there's no joint here. There is not triangle here. So it is not simple truss, and it is also not compound truss. Okay, this one is important. Determinacy. Determinacy, total unknown forces in B, total unknowns equal to forces. So you don't know the value of forces acting on the trusses, but you know the number of it. So the number of forces in B number of bars. So this is B number of bars of the truss plus the total of external support reactions. Define your determinacy. So forces, next we take a look at the equation. Force system at this joint is a coplanar and concurrent. The force acting concurrently and in the same plane. And rotational or moment equilibrium is automatically satisfied. So summation of Fy, Fx, and moment is satisfied. So this is the equation. B is the number of bars. B stands for bars. R stands for forces, unknown forces, or basically reactions. And then J is the joint, number of joints. The number of joints you have. So B plus R is equal to 2J, B plus R less than 2J, so it is statically determinate. But if B plus R is more than 2J, it will be statically indeterminate. And then 2J minus B plus R would define your degree of determinacy. Determinacy. Okay. Stability. If B plus R less than 2J, it will be collapse. Huh? So the structure is not stable because you don't have enough support, or you don't have enough members. And trust can be unstable if it is statically determinate. If it is statically determinate, it can be unstable, but also statically determinate but also unstable. So stability will have to be determined either through inspection or by force analysis. When you do summation of fx, for example, if it is not equal to 0, and it is not stable, it's not static. External stability. A structure is externally unstable if all of its reactions are concurrent. This we've talked about in video of frame, statically determinate frames. So if it is the force reactions are concurrent or parallel, like this one, like this one, all supports are roller, then the structure is unstable. These trusses are externally unstable since the support reactions have lines of actions. They are either concurrent or parallel. And this one is parallel. Parallel. This is concurrent. This one is concurrent. So you can see here, the truss will move downwards because it doesn't have enough support. Next is internal stability. Internal stability can be checked by careful inspection of the arrangement of truss members. So you check the truss members if the joint is held fixed so that it cannot move in a rigid body sense with respect to other joints, then truss will be stable. So the member here you can see it is attached with cross members here, so it will be internally stable. A simple truss will always be internally stable. Yeah. Triangle. If truss is constructed so that it does not hold its joint in a fixed position, it will be unstable or have a critical form. So the form is critical if it is not held in a fixed direction. To determine the internal stability of a compound truss, it is necessary to identify the way in which the simple truss are connected together. So how the simple truss is connected will define the internal stability. So the truss shown is unstable since the inner simple truss ABC simple truss is connected to the F using 3 bars AD, CF and EF, which are concurrent at point 0. This is concurrent at point 0. They meet at point 0. Thus, an external load can be applied at A, B, or C and cause the truss to rotate. So, if you apply load here, so the truss would rotate in this direction because there is no restraint, because the uh, support is concurrent, pointing towards one point. So there will be a rotation. So you cannot analyze a rotating structure in aesthetic. So you need to analyze it in terms of dynamic. So it is not a statically determinate structure. For complex truss, it may not be possible to tell by inspection if it is stable. And the instability of any form of truss may also be noticed by using a computer to solve the 2J simultaneous equation for joints of truss. You can also using computer. There's a lot of website here giving you free analysis on trusses. They can do simultaneous equations. If inconsistent results are obtained, the truss is stable or have a critical form. So you are lacking members or joints and supports. Okay, next video we'll take a look at the example to classify each type of trusses.